Hello and welcome back. Today I have something exciting, and it is a Keithley high voltage power supply. I'm a bit excited. I hope it is more electrifying than shocking because it can deliver more than 3000 volts. So I need to be very careful. Here it is from the front. We have the power switch. After you have switched it on, you need to wait at least 1 minute. Because the valves need to warm up. You can set your voltage. These are the 1000, the hundreds, the tens, and the last one is variable. It's now locked in. Now you unlock it, and then you can go 15 volts up. And they say you should be able to do around 200 millivolt precision with this. Yeah, it only goes up to 2, I see here. But this one goes from 0 to 10, so then this probably goes then to 3. And if you put this one to 10, it actually means it goes here, so then you have 3, 1, 0, 0, and that makes sense here, 3, 1, 0, 0. But let's just start by just 100 volts, I think. Okay. And this meter, I have found some pictures, but they were all very low resolution because there is not much to find. I have a picture of a meter that is actually a centimeter. From the center 0, and then you can go negative 3 kV and positive 3 kV, and this one only does the positive. So you need to be careful with this machine because you just turn a knob and you just up and go 1000 volts up. And yeah, I'm a little bit scared, to be honest. It runs on valves to get these high voltages. So it's not transistor based or FETs, or it is a DC supply, but still they use the valves, the old tubes. I was just thinking, oh, we just play a little bit and let's see. And but then I'm looking at my multimeter, and this is a proper one, and the same for the fluke. But it just goes up to 1000 volts. That's it, not more. This one goes to 3000. So that's another problem. And then I look to all my meters here. They all go or below, like 300 for the Keithley 199. Most of them it is 1000, some are 600 volts. I have one Keithley that is the 192, it can go to 1.4, so 1400. But that's still not enough because I need to go to 3000. So then I sent an email to the Eleshop. I said, how do you measure these high voltages? Do I need to make a voltage divider, or how does it work? Well, yeah, we actually have something for that. So to measure these high voltages, you need these high voltage probes. And well, this probe can do up to 40 kV, so it's more than enough. And on AC, 28 kV. Well, let's just open it. What this actually does, it is just a simple voltage divider, and it uses the impedance of the multimeter. So I unpacked it, and this is what it looks like. And now I'm getting even more scared. So this is your ground pin you put on your device. This is where you want to measure. And I learned from Chris from all the gear, you need to work with one hand. So it doesn't go from arm to arm if you get shocked. And the other side here, you just put in the multimeter. Well, then we have all the input resistance here is like 1000 megs. It says, well, approximately it should be, well, actually 10 meg less, but I will show you later. 40 kV. It is for multimeters, and if you measure 1 volt, it means you're actually measuring 1 kilovolt, so it's a 1 by 1000. Well, the input impedance of most of the multimeters nowadays are 10 mega ohm, but I was actually measuring it, And it is not automatically every range has the same impedance. So that also means we need to take it out of the auto mode and then put it in a range where it is exactly 10 mega ohm, or yeah, we will not have a good reading. So this probe actually works with the simple principle of a voltage division. So if you have here your internal resistance of 10 mega ohm and you just add your probe here with another big resistor, they said here it was 1000 mega ohm, so that means, well, it's probably in 1990. And then you measure in between here, then of course most of the voltage will end up over this one and not here. I will send a nice link on a video about that, but Chris did. Well, let's just see if we simply can measure this impedance. It is now in DC auto mode, so I will just put it in ohms to wire mode. And just put it in. And you see now it's in auto mode and it is in the 5 volt range. And now it's a little bit more even than the 10 mega ohm. So that means that if you make this voltage divider, you will measure a little bit too much. Well, actually 10% too much. So that is not good. So what I want to do is put it in manual range. This should be the 50 volt settings. So that means we could measure up to 50 kilovolts. But as you can see, we are still off. This is 1% off. So if you don't want that, you need to be closer to the 1 mega ohm. So if I do another range up, this is the 500 volt range. And we're actually pretty good. Now we are very close to the 10 mega ohms. So this would be good. We can measure up to 500,000 volts, which is a bit too much. But maybe if I add an extra digit, yes, now this still would be good because we still have a lot of digits, just as much digits as we have knobs to set. And here, yeah, would be better to do another scale, but then we lose here a digit, and then I think the difference here is not more than losing the digit here, because if I go now to the 50,000 volts, then it is spot on. But it means we lose a digit. I think I go one scale below. Okay, that was the quick theory. Now let's try to switch it on. First, because it was shipped and it is from 1967, I just quickly want to open it just to see if it sort of looks good, if one of the valves maybe not is out of his socket or anything. Here it is from the top. Let's get a little screwdriver. Open this. Wow. It is full of valves. I'm not so into valves at all. It seems they have 2 big ones here, 2 small ones. Probably a little rectifier. And then, I don't know, somehow they get the voltage up high, or that's just with the transformer. I don't know exactly how this works, to be honest. Some very old capacitors. Well, the main board doesn't look that bad. It is, well, almost 60 years. Well, now I'm getting to the point that I need to try it. And well, I will check if yeah, it switched to a positive. I see here a BNC. So somehow in that BNC, I need to get my voltage out. But I'm not sure if BNC even get that hold high voltage. Yeah, here is that BNC connector. This is the output. And of course I have these. But this is usually for low frequency, low voltages. So, and I don't see a rating on it, but if usually the meters are for 1000 volts, I also don't trust this one to go above. So this doesn't feel good somehow. And I do have here an extra plug. It is a banana, so that is good. So I can use that. And I found something like this. And I never knew what it was for. But now it starts to make sense. And I have two of these. I bought this in some sort of kit. And these things here look like that it can just go over the BNC. And then like this. And now it feels a lot better. Because then I can just put my plug here and here. And this is far enough away for any spark bridge. Okay, now we come the scary bit. Need to plug in the power plug and switch it on. Switch it on for a minute. Set the correct voltage. We just started 100. And switch then the outputs on and try this voltage probe. Okay. I think I'm ready. Using my gloves. I should have used other ones, but it saves me a little bit. I put my meter again to the 500 volt setting, and I need to plug these in. I need to switch on the power and let it just go for a minute. Well, the light is on, that is a good thing. I have my ground, the ground pin. Connected. Okay, it has been switched on now for a few minutes. It is set to 100 volts, so that should be really below there. Connecting my pin, switch on the output. Yes, it indeed goes a little bit up here. And yes, we have here 19.7 volts. So 200 volts. Yeah, almost 200. Now you can see that it is a little bit off. $300, $400, $500, and you see the scale going up. 6, 7, 8, 9, 10. This could also be because it says now 990 volts, and it should actually say 1000, but it doesn't. And that could be of this 1%. 990. Let me go. 0 and 1000 volts. And it is now also 995. And the meter here is also to 1000. Let me turn the camera a bit. Let's see what happens if we go up. I will switch off the output and it drops. Okay, here we go again. One hand, the other one in the back, but I need to turn my switches. So maybe this on and then yes. And as you see, we are at 10% or 1% off, but it's okay. Now it's even 0.1. So this is 2000 volts. Let's see if we can go to 3000 if the device works. I think you need to do your output off and then set the value. And poof, it goes to 3000 on the meter. And here we have also almost 3000. Let's try it to the highest. So this would be, it's 2 plus 10, it's 3, 1, so 3, 1, 0, 0. And then we can add even a few volts extra here. Here we go. Yeah, it goes off the scale, and indeed it's almost 3.1. And we can add a little bit here. Here we are, 3100. A lot of volts, scary. And let's put it down to 1000 volts or 500 volts and then see what it does without this high voltage probe connected. I set it now to 500 volts, 500. I'll measure with the pin and switch the output on. Here it says indeed 500. Here it says 497, 498. There it is. Okay, let's see what it is without this high voltage probe, because 500 we can measure. So remember, 498. Outputs off. Okay. Okay, here we go. Does it also say 500? 498. So this divider on the 500 volt setting, look at that, that is perfect. And what would happen if we use it indeed above 1000 volt? Will I blow the meter? No, I'm in the wrong scale. .600 volts, 700 volts. Oh, it goes higher. Look, 1200 volt, 1300 volt, 1400. I will stop. I don't want to blow the meter, but it just does that. Perfect. Yeah, so that worked very nice with the high voltage probes. I was really impressed and I really got scared. And I think you should be scared, so don't try this at home. But you get used to it also very fast, because I started with a screen and 2 gloves, then I had only 1 glove, and then in the end I just used normal to try to think really what I can touch and what I cannot touch, because I didn't feel a tickle, and that is exactly the danger. Because if you do something wrong and you do grab without glove something, you get shocked, and it is DC voltage, so it is really dangerous. So I already cleaned the front, and it really looks a lot better. There is still some coloring here for a sticker that has been there maybe for, I don't know, 30 years. So you can still, because of the infrared light of the sun, but the rest is now a lot better. Also, I try again the trick with the brush cleaner. So these are now almost transparent, and this is an old one. You can see it is like milky, and these are like glass clear. So also again, I just use a brush cleaner carefully, not to wipe out the numbers, but just do the glass. And look at this. If you have this or this, what the difference it is. Now this, it from the front, when it's clean, all the fingers are out, it really looks a lot whiter. And if we zoom in on the rotating switches here, this one is like glass clear, and this is all milky. So this one I need to do still with the brush cleaner. But as you can see, it really makes a huge difference. So I'm gonna continue that. Okay, that looks so much better. The numbers are all very clear to read. Only thing we need now is the polarity switch. Hopefully I have something. So I have my drawer of all kinds of buttons, knobs, etc. Some I just order in China, some I just have from old radios. I think this could be it. It looks kind of classical also. And if it fits, that will be my choice, because this is very different. The rest is too big. It will be this one. Well, it does look nice, but it doesn't fit it is a very tight fit. So I will try to drill a little bit. So that is done. That looks a lot better. Yeah, drilling it bigger, that went not completely fine, but I saw it was yellow copper, so I just used the drill bit backwards, and then it didn't grab, and then it worked. So I was able to put it on there. This is the knob, and I was just playing a bit with the multimeters. Yeah, and with the Bremen I could just put it over 1000 volt and it was still giving a value. And now I'm here the hold peak and it's set to 1000 volt. Can you see the display? I think you can. And if I put to 1000 and I do one more, over. So this one does not do above 1000 volts. Here the Kaiwitz, I will put it manual to voltage. Here we go, 1000 volts. Here we go. It says 1000. I do a little bit more. Overload. Then I thought, oh, okay, must be because they are all cheap brands. And then I'm here with the Fluke. And I switch it on, 1000 volts. But the scale can go to 4000. But it doesn't do it. And then I did the same thing with the Bremen, and I did it actually accidentally. But there, because the scale is 5, so the scale could go to 5000. Of course, the meter is only made for 1000 volts. So if you switch it on, I go to 1000. Can you still see that? I think yes. Okay. Then I do a little bit more. It keeps doing that. It just goes up to 2000 volts. So that's the Keithley 246, still working perfectly. The voltages we could adjust perfectly. Now it's clean and I think it looks amazing. Was also my first experience with voltages above 1000 volt. And it was a little bit scary, but with the proper measures you can work on it safe. And I enjoyed. Thank you for watching and I hope to see you next time.